Hey everybody, hello. How you doing? I hope you're doing all right. We are in May. We're actually only a few weeks from the end of school. Not too bad, huh? We're going to finish this chapter and do chapter 8, and then we'll be good to go. So the end is near. Keep up the hard work, guys. You're doing a really good job. So I'm going to give you this little video that goes over the review for the first half of chapter 7. And let's get right to it. First question, the first few questions are multiple choice. What's the domain and range of this function? Remember, domain for an exponential function is all real numbers. So even though this goes up forever, which it does, it also goes this way forever. So it's going up and out. So it's everything. There's no x value that won't work. So we don't have to worry about a or d because all real numbers is a part of the domain. And now, notice how that flattens out. This flattens out at 0. So notice how every part above this graph is greater than 0. It's all above the y-axis. I'm sorry, the x-axis. So that means y is all numbers greater than 0. So it is C. Okay. Solving this equation. Remember, if you need to solve this equation, you need a common base. The base we can use is 2, because remember, 2 squared equals 4. 2 cubed equals 8, so we can turn this 4 into 2 squared. Don't forget our 2x. And turn that 8 into a 2 cubed. We got an x plus 4. Same basis, so let's simplify. Let's multiply these exponents out. This is 2 to the 4x equals 2 to the 3x plus 12. Since we have the same base, we set the exponents equal to each other, and we just solve the equation. Subtract 3x, we get x equals 12, and lo and behold, we got a nice little 12 right there. So, good job. Let's keep on going. This is just basically definition. How do you turn this into a logarithmic form? Remember, the 4 is the base. It's the base of the exponent, it's the base of the logarithm. And then we just kind of switch these two. Because remember, 4 is the base. 4 to the 3rd power is 64. So this is correct. Log base 4 of 64 equals 3. And that'll help us with the next problem. Because if we know how to convert those bases, we can kind of know what to do. Like that might equal something. Not sure what it's going to be. We'll say it equals y. Okay? So I'm going to rewrite this 4 to the y power. So 4 to some power equals 32. Now, unfortunately, it's not just going to be 4 squared or 4 to the 3rd, because 4 squared is 16, 4 to the 3rd is 64. It's right in between there somewhere. But these both have bases of 2. Remember, 4 is 2 squared. I'll put that little y with it. 32 is 2 to the 5th. So with that in mind, same basis, just solve for y, divide by 2. Y equals 5 halves, and we got her right there. Alright, very nicely done. Let's move on. We get a little inequality here, but no big deal. Inequalities they're people too. They can be solved. Okay, this is weird. Oh, weird thing to say. Good news is, logs are both log base 3. So all we have to do is set this greater than or equal to that, and we solve. So let's take 7x from both sides. Negative 3 is greater than or equal to negative 2x. So now I'm going to divide by negative 2. Remember, if you divide by a negative, you flip the sign. So that leaves me with 3 halves is less than or equal to x. And again, I'm going to write the x first, which means I'm going to flip the sign again, because the big mouth opening is going to go towards the x. X is bigger than 3 halves. Now we always have to check for negatives. So if I put 3 halves in for 7, I am okay. Because 7 times 1.5 minus 3 is bigger than 0. So I don't have to worry about it. X is always going to be bigger than 3 halves. So I got A right there. 6 and 7, pretty straightforward. Just write it in logarithmic form. Remember the base is 5. And your exponent is 4. This means 5 to the 4th power equals 625. So here's our answer. Here, going the other way around. 7 is your base. Remember, 7 squared equals 49, which, whoa, what was I going to do? Don't write that one. 7 squared equals 49. There we go. Okay. Whoa. That's when you get a little like I've been doing too much work. Okay. Bases are good. Log base 5, log base 5. So we just got to set the exponents, or the expressions equal to each other. Not equal, because this is greater than 4x. Alright, I'm going to solve it like normal. Subtract 2x from both sides. And we're going to get 2x, right? Because 4 minus 2 is 2. Divided by 2. I get this expression right here, that negative 1/2 is greater than x. I like to draw the x first, however, because it's just easier for me to think about. And again, I'm going to flip the sign around, mouth opening, going to go with the negative 1/2. So this says x is less than 1/2, which you see right here. So you might be thinking, yeah, there's my answer. But be careful. Remember, you cannot take the log of a negative number. If x is negative 1/2, then this is going to become negative 2. We can't do that. So remember, we have to set these equal to 0 and see what we get. So, because it has to be greater than 0. It has to be. So let me add 1 to both sides. Let me divide by 2. So it seems like I got contradictory statements. See, x has to be greater than 1/2, but x also has to be less than negative 1/2. But you know what? It never will work. There's no solution to this equation. The algebraic way that it will work will not fit. So there's no solution. All right, a little trick question to throw at you. Hopefully you were all right there. All right, write it in exponential form. Our base is 1/5. Exponent is negative 2. Equals m. That's all you had to do, because I just had to write it in exponential form. However, if you wanted to solve it, what would m actually equal? What's 1/5 squared? It's 1 over 25, and that negative means you flip it over, it'd be 25 over 1. All right? So it's a little step further than we had to there. All right, 10 and 11 are very similar problems. You have to use a calculator to figure these out. Remember, our exponential growth model is usually a times b to the x, but in some cases we're not given the growth rate, we're given the percentage rate. So if it's a growth, we got to add that percentage to 1. 1 plus something is it grows. When we lose money or lose things, it's 1 minus the rate. Okay? Here's how it works. A is your starting value. We're starting at $300. The rate is 5.8%, which is 0.058. So when I do that, notice how that number, which would be the B number, if you think about it, is greater than 1. Remember, if this number is greater than 1, it's an increase. So in this case, I just want to find out what happens after 10 years. So I'm going to pop this into 10 right here, and then I'm just going to put it on my calculator. All right, that's it. There's no fancy way about it right there. So 300, 1.058 raised to the 10, and I get $527. This is the nearest tenth. Well, that's weird for money. Well, it's going to be 20 cents, 0.2. That's how much money you're going to have in your account after 10 years. Really not much, but if you think about it, you almost not quite doubled the money. So, smart move. Instead of putting $300 in there, try to put $3,000 in there. That way you have over $5,000 in 10 years, and you did absolutely nothing. All right, I try to get 5.8% interest. It's not easy to do. All right. Obviously, you've heard of the sequel coming out, Kevin Strikes Back. I don't give you too many details about the movie, but let's just say it's about me. And being released on my birthday. What an honor. Now, my production company says they anticipate a $68 million opening weekend. That's good, because movies always lose money exponentially. The next week they'll make less and less and less. It actually looks like an exponential curve down, so exponential decay. So we have a 40% decrease every week. So we're going to use this formula. I'm going to start with 68 million. 1 minus because I'm losing money. 40%. Now if I subtract it, what do you notice? What is 1 minus 0.4? Well, it's 0.6. And guess what? 0.6 is less than 1. That means it's going down. All right. I want to know how much money 5 weeks later is this movie still going to make? Because the more money it makes, the better it is for me. 68 million times 0.6 raised to the 5th power. Oh, that's still all right. In the 5th week, it's going to make $5,287,680. I'll take that. Oh, over a month later, still making them $5 million bucks. That's all right. That's all right. For fun, you should check out some movies. Go to boxofficemojo.com. Check out how much money movies make week by week. You notice how they always go down. If you graph them, it's pretty exponential. So I actually kind of answered number 12 as we were doing 10 and 11. How do I know if it's growth or decay? Well, I just look at the number in there, 8/5. Remember, if it's bigger than 1, it's going up. If it's less than 1, it's going down. 8/5 is bigger than 1, isn't it? So it is a growth. All right. There we go. Good job, people. A few more to go. We'll be all set. All right, we're going to graph this. Remember, 8, that's where we're starting. 1, 2, 3, 4, 5, 6, 7, 8. Now, since the growth rate is a half, it's gone down. That means every time I move over 1, it's going down. So if I go 1, what's half of 8? 1, 2, 3, 4. Next one, what's half of 4? 2. What's half of 2? 1. What's half of 1? A half. So you see how now it's starting to curve a little bit. I'm not going to draw really well, but it curves really sharply. It goes up forever this way, and here it's going to level out at 0. And now if you wanted to make a table, you certainly could, because we talked about tables before. There's my x, there's my y. At 0, I've got 8. At 1, it's 8 times a half. At 2, remember 1/2 squared is 1/4. 8 times 1/4, or 8 divided by 4, is 2. So you notice the more I go up, the more that drops down. 4, and then a half. And I can keep going forever. 5 would be 0.25, and so on. Alright, so what's the domain? Our domain is always all real numbers. You know, I like that little sound. We'll just write it out. All real numbers. Or if you like that little symbol, you could say that D is the little all real numbers with the little extra line in front. And the range is your y values. Again, it levels out at 0. It's everything above 0. It doesn't equal 0, but it's above 0. That's your domain or range. Alright. I haven't done this one in a while. But remember, your basic exponential function is a times b to the x. A is where we start. Well, guess where we're going to start. 5. That's where we're starting. So I'm going to borrow this point to figure out my b value. I know my y value will be 40. I've got my 5. I don't know b, but my x value is 3. All right. Divide both sides by 5. I get 8 equals b cubed. All right then. What's the opposite? Or not? Yeah, the opposite of a cube is a cube root. So what's the cube root of 8? Or what cubed gives you 8? It's 2. So your equation becomes 5 times 2 to the x. That's how we do those problems. All right. Now I got a couple equations to solve. Let's see how things go. All right, in order to solve this, I've got to, what can I do? Kind of write it as similar bases. Now, I can use 4, because what is 1/4? It's 4 to the negative 1, just flipped over. What is 16? It's 4 squared. So what I'm going to do, in place of 1/4, I'm going to put 4 to the negative 1. And that's gone to the m minus 7. And 16 is 4 squared. So let me multiply this out. Multiply the negative 1 through, I get negative m plus 7. Now I have the same base, so I can just set the exponents equal to each other. Alright, subtract 7 from both sides. Negative m equals negative 5, which means m equals 5. Alright, very good. Very good, very good. Almost there now. Okay, well, we need those same bases again. Well, luckily 100 is 10 squared, so we use a base of 10. So I'm going to rewrite 10 x plus 3 greater than 10 squared x minus 1. I'm going to multiply this through 2x minus 2. Same base, so our bases are good, so now I can set the exponents like this. X plus 3 should be greater than 2x minus 2. Okay, now we'll just solve. Subtract x from both sides. We get 3x minus 2. Now I'm going to add 2 to both sides. 5 is greater than x, but you know we got to write the x first. We don't have to, just I'm so used to doing it that way. X is greater than 5. I'm sorry, x is less than 5. Now, is that okay? Can you have a negative for this one? Because we're getting everything less than 5. And we can. We're just, exponents can be negative. They're fine. Okay. So my answer is all x is less than 5. Alright, last 4. Write this in logarithmic form. Well, hopefully you're getting really good at that by now. So your base is 5. So it's log base 5 of that equals negative 4. That's your logarithmic base, or logarithmic form. Alright, now we're going to use that to evaluate. So, you know, we don't know. We'll just say y. Let's rewrite it. So 6. So 6 to the y power equals 6 to the 8 power. Oh, wow. All right there. It's like given to you. If your base is the same as that number, keep that in mind for the next half of the chapter. Okay. Let's figure this one out. So we have 64 raised to the 2/3 equals x. Oh, okay. Now he's going to do this. So what's the cube root? Remember, the 1/3 is the cube root over 3 is the cube root. The cube root of 64 is 4. 4 squared equals 16. Hopefully you're good at that by now. If not, you will be. All right, last question. Oh, our logs are the same. My goodness. Where's the challenge? Notice I just noticed on here there's no squares. There might be a square on the quiz, just so you're aware. So look back to the last section if you're not sure. Anyway, we're going to solve this. So subtract 2x, subtract 2x, and that's x minus 2. Add 2 to both sides, and we'll put it over here. 7 less than x, which means x is greater than or equal to 7. Well, if x is greater than 7, we really don't have to worry about negatives, because anything greater than 7 is going to be positive in here. And if I put 7 in here, I'm going to get a positive. So I'm okay with that answer. And let me just say 7 is 21. 21 minus 2 is 19. 2 times 7 is 14, plus 5 is 19. Yeah, that's good. All right, there you go, people. That is it. So hopefully you had a good time. Who doesn't have a good time doing reviews, huh? And I will see you another time. Bye.